And now we move on to insulation and roofing. So for mandatory measures, the following openings in the building envelope shall be caulked, gasketed, weather stripped, or otherwise sealed. The exterior joints between conditioned and unconditioned space, any openings for plumbing, electricity, and gas lines on exterior surfaces, any openings in the attic floor, and or any openings around exhaust ducts.
Weather stripping is required for all field fabricated operable windows and doors. This does include doors between the garage and living space and doors for HVAC closets and attic accesses in the living space. All other such openings in the building envelope. So essentially, if there's a hole, there's an opening, there's a door, any way that that air can move from the outside to the inside of the home, it does need to be sealed, weather stripped, or caulked to prevent that movement of air. Now, continuous stucco, building wraps, and exterior rigid wall insulation can be used as an alternative technique to meet the mandatory caulking and sealing requirements. So here we have the prescriptive values for wall insulation. And in the table here, you'll see it broken down into above grade and below grade walls, and then further broken down into framed and mass type walls. So most commonly what you're going to find out in the field is going to be an above grade framed wall, and we have two different targets based on what climate zone that we're in. So for those that are climate zones 1 through 5 and then 8 through 16, we have not an R value target, but a U factor of 0.051. In climate zone 6 and 7, it's a 0.065. So what this is the overall assembly U factor. So this takes into account not only the insulation that goes into those walls, but also the thermal properties of the framing members, any exterior insulation, if it's a stucco or sheathing on the outside, it takes all that into account. And so we're going to look here next at some of those different structures, how they're built up, and what their equivalent U factors are. In this table we have 6 different assemblies and their construction type, cavity insulation, exterior insulation, and that equivalent U factor that can be used within the system. So we saw in climate zone 6 and 7 that a 0.065 was our prescriptive requirement, and so that can be met by building a 2x4 wall, installing a R15 high density bat. So normally we'd see an R13 in a 2x4, so we'd have to increase and go with a high density R15 bat. Include an R4 exterior insulation, so a foam board on the outside, and that's going to give us that U factor of 0.065. Now for our walls in all of the other climate zones, we have 5 different options on how to comply. So we've got 2 of them that are at a 0.051, 2 at an 0.050, and then 1 that's an 0.049. Again, we can be better than the target, and in this case that would be a lower number, but we can't be worse than. So our first option is to go to a 2x6 wall, and actually our first 2x6, we can go with an R21 high density bat or loose fill cellulose. Normally we're going to see an R19, which is kind of that second option for 2x6, just a standard R19. If we go with the R21 option, we only have to do an R4 on the outside, where if we do the R19 option, we got to do an R5 on the outside. So there's a little bit of a trade-off there. Do you want to go with a high density bat or standard, and you want to go with a little bit thinner or thicker insulation on the outside? Both of them will get you that 0.51, but it's 2 different options to go. Now if you want to go and stay with a 2x4 wall construction, you'll still go with that R15 high density bat on the wall, where now you're going to have to go with an R8, which is significantly thicker than the R4 on the outside. That's going to get you to a 0.50. If you're going to go with a spray foam option, you can go with a 2x6 wall, go with an R31, which you can achieve with that closed cell spray foam. Now you only have to do an R2 on the outside. That's going to be very thin, and get a 0.50. And finally, you can go with a 2x6 wall go with a high density batt or mineral wool, which will get you an R23, and you can stay at just an R4 on the outside for a total U factor of 0.49. So a lot of different options, but these are all more than what is standard for the builders right now. So it's going to be a change in that overall construction process.
Now the mandatory minimums, so we talked about prescriptive, the mandatory minimums for walls is an R13 at 2x4 and an R19 at 2x6. Both of these minimums don't apply to frame walls of conditioned basement, crawl spaces that are below grade, and rim joists between stories are allowed to have R13 regardless of the wall size. So there are different values that are used to meet the criteria for metal frame assemblies and mass walls. We're not going to cover these. This presentation mainly covers just wood frame construction. However, if you want to look these up, the separate criteria that I just talked about can be found in the reference joint appendix JA4. Batt and loose fill insulation should fill the wall cavity evenly, and then insulation should extend into the perimeter floor joist cavities along the same plane as the wall, obviously to extend the insulation the furthest out in the wall. If a vapor retarder is required, it must be installed on the conditioned space side of the framing, so basically on the interior side of the wall. And then always the R value of the installed insulation should meet or exceed the values found on the CF1R. And I know that we're listing this in the wall insulation, but that's the case for any insulation. You should always match or exceed what's found on the CF1R. Now for the floor, it's easier, just an R19, prescriptively required throughout the state for floor installation. Obviously we're talking about a raised floor. The R19 is also the mandatory minimum for the state as well. So for floor installation, the mandatory minimum and the prescriptive requirement is the same, R19. Again, just like the walls, different type of raised floors, basement, crawl spaces, etc., have different installation requirements, and these separate requirements can be found again in reference joint appendix JA4. Now slab installation is a little different. So slab installation is prescriptively required in climate zone 16. So prescriptively, R7 slab installation is required in climate zone 16. And while not a mandatory measure, there is a product suitability requirement that can be found in Chapter 3 of the Residential Manual, Section 3.1.22. So depending how that installation is installed, there's different products that you have to use. As long as they are R7 in climate zone 16, though, you're fine. When slab installation is required by the prescriptive or performance approach, the minimum depth is 16 inch or to the top of the footing, whichever is less. And these are examples of where that installation would go. So on the top left hand side, you have interior insulation. On the top right hand side, you'll see how the insulation is placed on the outside of the raised floor. On the bottom left, the insulation is placed beneath the slab. And then in the bottom right, it's basically radiant floor insulation where the insulation is placed on top of the floor. Now, what we were talking about earlier, we were saying that each installation type has its own material product requirements. This is what we're talking about. So depending on where the installation is being installed, there's different products that are approved for that particular application. Now for heated slab installation, the radiant floor systems and the concrete slabs must have insulation between the heated portion of the slab and the outdoors. So don't confuse this with regular slab installation. In climate zone 16, the slab installation is prescriptively required whether that's a heated slab or not. But if you have a heated slab anywhere else in any other climate zone, the slab installation is also required because you have a heated slab. So basically here, this table shows you the climate zone on the right hand side and basically the insulation R value based on the climate zone that you're in and how you're supposed to install it based on that scenario. And again, examples how the heated slab insulation would be installed, which is very similar to the other slide that we saw a second ago.
Ceiling and roof insulation has seen some big changes for 2016 on the prescriptive side. So no longer do we have just simple R value requirements for different climate zones. They have been replaced with three options: option A, B, and C. So the first two options are for what we call a high performance ventilated attic. So essentially what this does is requires insulation to be installed both at the roof deck as well as at the ceiling level. Now these are going to be just standard ventilated attics, so you're still going to have regular attic ventilation, but we're now having insulation at two different points. So option A is going to be that vented attic with continuous insulation applied above the roof deck. So this is on the outside of the roof sheathing, and then as always, ceiling insulation required above the finished attic ceiling in the normal place you would see it. Option B is very similar, vented attic, but this now is going to have batt, spray in cellulose or fiberglass secured with netting, or SPF, spray polyurethane foam, and these are going to be below the roof deck. So these are going to be inside the attic space, and this also going to have regular ceiling insulation at the attic ceiling. So we're going to have those two different types. Or your third option is to have a vented attic with no insulation at the roof deck. However, your ducts will have to be completely within conditioned space. What they're trying to do here is they're trying to lower attic temperatures. So when your ducts are in that condition or in that attic space, if we can lower that temperature, then we're going to have less heat transfer through the duct insulation, making those more efficient. Or if we just move the ducts into conditioned space, it really doesn't matter as much how hot the attic gets, because we're not going to have those ducts affected by those high attic temperatures. Now these options A, B, and C are really only going to affect climate zones 4 and 8 through 16. So in this table here, we kind of break down what's going to be required, not just insulation for your ceiling and roof, but some additional items. So for option A in climate zones 4 and 8 through 16, we're going to have that vented attic. We're going to have an R6 if there's an airspace, or R8 with no airspace for continuous above deck rigid foam board insulation. We're going to need R38 for the ceiling insulation. A radiant barrier must be installed. We're going to do R8 for our ducts, and a 5% total duct leakage. In climate zone B, for option B, again in climate zones 4 and 8 through 16, the same vented attic, where now we're going to need an R13 with an airspace, or R15 with no airspace for our batt, spray in cellulose or fiberglass below the roof deck, secured with netting or spray polyurethane foam. We're going to need that same R38 for the ceiling insulation, R8 for ducts, and 5% total duct leakage. For option C, which is the ducts in conditioned space, we're going to do that vented attic. We don't have the requirement for the roof deck insulation, so we're just going to be either at an R30 or R38 for the ceiling insulation. That's going to be climate zone specific, and we'll look at that here in a second. R6 or R8 ducts, again climate zone specific, and then radiant barrier and verified ducts in conditioned space. And for that, you're going to do a leakage to the outside, and you cannot leak more than 25 CFM. So a little bit different than options A or B. So what do we have for requirements in climate zones that aren't 4 or 8 through 15? So we look at the table here, we can see any of those climate zones where at the top for option A has an NR, which means not required. We can just go down to the third row there, ceiling insulation, and we're going to see it's going to be again climate zone specific. So in climate zones 1 and 2, it's R38, where climate zone 3, it's an R30. Same thing, we've got climate zones 5 through 7's R30, and then climate zone 16 R38. So it's going to be very climate zone specific. Same thing for your radiant barrier. Climate Zone 1 is not required, but Climate Zone 2 it is required. So let's look at option B next. So option B is going to be very similar. Again, it's going to be climate zone specific, either R30 or R38, and then the potential for a radiant barrier depending on which climate zone that you're in. And finally, option C, again, climate zone specific. As we mentioned in that first table, we're going to have R30 required in climate zones 2 through 10, and then R38 in climate zones 1 and 11 through 16. Radiant barrier is going to be required in climate zones 2 through 15 for option C. So for our mandatory measures, the mandatory minimum is going to be R22 or an overall U factor of 0.043, and this will be for wood framed roofs only. There are different standards for metal roof and other roof assemblies, and those can be found in Reference Joint Appendix JA4. And then we do have 3 different ways to meet the prescriptive requirements that we saw. The first one is just to meet the minimum prescriptive insulation standards. If it says R30, you install R30. Our option number 2 is to use a different roof assembly that can be found in JA4. There are metal roof assemblies, there are rafter type assemblies. So if you're doing something other than a standard wood framed roof, go to JA4 and meet the requirements that they have listed there. And then finally, you can use the Energy Commission's Easy Frame Assembly Calculator. That will give you the U factor of the type of assembly that you want to build, and as long as that assembly meets the minimum requirement or prescriptive requirements for U factors, then it will comply with the requirements.
Ceiling insulation should extend far enough to the outside walls to cover the bottom chord of the truss. So basically, it's made to extend the insulation out the furthest out possible. Loose fill insulation must be blown evenly. It also needs to meet the specified weight per square foot for the corresponding R value for fiberglass and mineral fiber only. And then insulation should not block the E-vents, and you have to use baffles to keep the vents unobstructed.
Now, E-vent baffles will need to be installed regardless of whether you are installing above deck insulation, below deck insulation, or no roof deck insulation. It's just ceiling level insulation. Now, baffles do serve a couple of purposes. The first one being that it will keep insulation from blocking the vent. Bad insulation can usually just be placed a little bit back, and it would be fine. Where loose fill is going to blow right up against it, it's going to plug that vent and not allow it. Now, the second purpose for it is to prevent air movement into the insulation, or even air movement to move the insulation. If it's loose fill and you have wind blowing in through that vent, it can blow that insulation away, and now you have exposed ceiling to the attic. At the same point, insulation that has air moving freely through it cannot do what it needs to. It will then allow a thermal bypass into the ceiling and increase the ceiling temperature at those areas. So 2 reasons to have those baffles. As you can see in this one, baffles really aren't going to be affected, or the above deck's not going to be affected by baffles, but we'll look next at the below deck, and you will need to have 2 different types of baffles installed. So with the below deck insulation, you can see the ceiling insulation is going to be baffled just like we saw in the previous slide. However, now that we've got a below deck insulation, and in particular we've got a loose fill cellulose or fiberglass, something that is air permeable, we do need to provide a second baffle, so that when the air comes in through the first baffle, it moves up the roof deck, it needs to hit that second baffle and be redirected around the below roof deck insulation. So again, we don't want the air movement through there. Air movement through insulation doesn't allow it to do its job, and it's going to decrease the effective R value of that insulation. So we do need to have both those baffles installed.
And these are examples of baffles that you might see in the field. So on the left-hand side, it's simple cardboard baffle. In the middle example, those are actual baffles built specifically for that purpose. So it's product that is bought and installed for that specific purpose. And then on the right-hand side, looks like a field fabricated baffles, literally some cut 2x4s and plywood to keep the insulation in place and keep it from not covering the vents. So each one of these examples is perfectly okay, as long as it's doing what it's supposed to be doing.
The California Building Code requires a minimum vent area to be provided in roofs with attics, including enclosed rafter roofs creating cathedral or vaulted ceilings. Now, attic ventilation, particularly in hotter climate zones, can provide an energy benefit. The easier it is for the hot air to get out of the attic and be replaced by the cooler outside air, the lower the temperature is, the better job your insulation can do. However, there is no energy credit allowed for increasing the ventilation area above the building code requirements. You can model it, but there is no energy credit allowed through the performance method. Now, there are two options given within the CBC. Builders will need to check with the local jurisdiction because different jurisdictions will have different requirements. But that first option is to have your net free ventilation area be not less than 1/300th of the area of the space ventilated. Now the second option is going to be to have the net free ventilating area be not less than 1/150th of the area of the space be ventilated. So either it's going to be 1 in 300 or 1 in 150. Again, it's going to be up to the local jurisdiction to decide which option they want. Now for option 2, that ratio can be reduced to 1 in 300 if a class 1 or 2 vapor barrier is installed on the warm-in winter side of the ceiling.
So in either situation, a minimum of 50% of the vents must be located in the upper portion of the space being ventilated and at least 3 feet above the eave or cornice vents. Ventilated openings are covered with corrosion-resistant wire cloth, screening, or similar mesh material. And then when part of the vent area is blocked by mesh or louvers, the resulting net-free area of the vent must be considered when meeting the ventilation requirements. So there's different standards for ventilating solid rafter spaces. So everything that we talked about as far as attic ventilation is concerned, we're talking about a regular attic. Now, a solid rafter space is an example of a cathedral ceiling or somewhere along those lines. So each framing cavity for a solid rafter space requires its own vent opening. There's different materials that will call for different approaches, and it's also at the discretion of the local building official. So there might be specific requirements depending on the climate zone, on the jurisdiction that the home is being built in. But keep in mind the solid rafter spaces are a separate application than the regular attic that we just talked about. There are additional insulation requirements that are present for QII, quality insulation installation, sprayed insulation, metal framing, log homes, straw bale construction, structural insulated panels or SIPs, or insulating concrete forms or ICFs. So we're going to be discussing a lot of these additional items in the QII section later on. So you'll hear some of these items again.
Radiant barrier is prescriptively required in climate zones 2 through 15 for options A and C, and climate zones 2, 3, and 5 through 7 for option B. The purpose of radiant barrier is to reduce the radiant gain to air distribution ducts and insulation below the radiant barrier. So if we look to the picture at the right, we have the sun at the top, and the sun is going to increase the temperature of the roof deck as it absorbs solar energy from that heat. As it absorbs that solar energy, if it does not have a radiant barrier, it is going to then radiate that absorbed heat into the attic space, increasing the attic temperature, making the insulation, HVAC equipment, and ducts work harder because now you've got a much larger delta T between the attic temperature and the inside of the home. Now with a radiant barrier installed, that roof deck is still going to heat up the same as the other side. However, that radiant barrier has a much lower radiance to it, so it doesn't radiate that heat into the attic. It doesn't allow it to transfer from the roof deck into that attic space. If you go back to our basics of building science, we have radiation, conduction, and convection as the methods of heat movement. Well, radiation, that radiant barrier blocks that radiation into that attic, lowering our attic temps, and it makes the insulation more effective on our ducts and our ceiling insulation. So there's a couple of different ways that it can be installed. Any installation must meet the criteria specified in the residential appendices in RA 4.2.1, and there's multiple variants that can be applied, and we're going to look at those next.
So the first application, like I said, pretty common in residential new construction. So basically the radiant barrier is actually part of the roof sheathing. It's installed just like a regular roof. The radiant barrier comes from the manufacturer on the underside of the roof sheathing and then just put on just like any other roof sheathing. Now in this particular installation type, it's a two-step approach. So they basically roll the radiant barrier over the trusses and then they put the roof sheathing over it. This application is more of a retrofit approach. It's actually used a lot in retrofit applications. I've also seen it used where the builder is supposed to put on a radiant barrier and they somehow forget, so they have to go back and put it on after the fact. But basically, it's the same type of material found in the second example that I showed you. The difference is the fact that the roof sheathing is already installed in this scenario. They just go back and basically fix pieces of radiant barrier below the actual roof deck around the trusses, and they staple it directly to the framing members. This last application, they rolled the radiant barrier, same type of material, they rolled the radiant barrier over the inside of the trusses under the roof deck. The one thing that I want to point out on this picture is the fact that the radiant barrier, when prescriptively required, needs to wrap the whole attic. It needs to wrap the whole attic, including gable ends. So in this particular picture, the gable end will also have to be wrapped in order to be compliant. Now, as far as cool roofs, they are prescriptively required. The prescriptive requirement depends on the climate zone and the slope of the roof. And there are two exceptions to the prescriptive requirements. So the roof area, one of those exceptions is the roof area has integrated PV panels, meaning that if there are integrated PV panels, you're not going to have roofing material over that particular area. Or the roof construction has a thermal mass over the roof membrane with a weight of at least 25 pounds per square foot. And these are the labels that you might see on roofing products. They have to be listed by the Cool Roof Rating Council directory, and obviously those values have to be applicable. And those are the two values that we're talking about, the solar reflectance and thermal emittance. Those are the values that you'll see on the CF1R telling you what the targets are supposed to be. This is the same principle as a window label, except that this is specific to roofing materials. Now this particular slide, it's really just here to show you the difference between a regular roof and a cool roof, and the fact that having a cool roof doesn't mean that you're limited to the colors of tile or product that you're going to be installing. So basically, by looking at the colors, you would think the darker colors would be worse off, and they are, but nonetheless, you could still have a cool roof that is black in color. So as you can see, the reflectance is still 0.41 versus a regular roof that's 0.04. Now, the black tile is obviously worse off scenario than a gray tile, but nonetheless, it can still be considered a cool roof depending on the manufacturer. So it's all about the manufacturer and the product that's being installed and not just the color of the tile.
The solar ready requirement is a mandatory measure. So this is going to apply to any new single-family residence that is in a subdivision with 10 or more residences, and to all new low-rise multifamily buildings.
What is the solar ready requirement? So the solar ready requirement require builders to build homes in such a way where a solar system could be dropped in without a lot of modifications to the house. The solar system doesn't have to be installed, but nonetheless, these requirements have to be met in order to make the house ready for a solar system if one ever wants to be added. So the solar ready requirement includes sub-requirements for the solar zone location, the solar zone area, the solar zone orientation, the shading, and the electrical. So for solar zone location, basically it has to do where the panels could go if they ever were put in. So they can be located on the roof of the building, on the overhang of the building. For single family and multifamily, that's what the SF and MF stands for. For multifamily, they could be located on the roof or overhang or other structures located within 250 feet of the primary building. They could be located on covered parking installed within the project, or also they could be on trellises, arbors, patio covers, carports, gazebos, and other similar accessory structures. So that's basically identifying where the panels would go. Once you identify where they would go, you have to designate a specific area that's going to be reserved for the solar panels. So it has to be clearly marked on the plans. This is for both single family and multifamily. It may be comprised of multiple areas, meaning that you can split it or you can have just one giant area, and that's specific to single family. The total cannot be less than 250 square feet, again, single family. And then for multifamily, the total area cannot be less than 15% of the total roof area of the building after subtracting any skylights from the roof area. And that's specific to multifamily. And then there are multiple exceptions that are present in the code for both single family and multifamily to kind of work around these requirements. So bottom line is, for single family, the solar area cannot be less than 250 square feet. For multifamily, it cannot be less than 15% over the total roof area of the building minus skylights. Once you identify where the area is and how big it's going to be, you have to make sure that that area meets a certain orientation. So if the steep slope roofs are used, they shall be orientated between 110 and 270 degrees of true north for both single family and multifamily. As long as they meet those particular orientation requirement, they're good to go. For low slope roofs, there are no orientation requirements. Now for shading, the solar zone shall be free from roof penetrations and any obstructions. Each obstruction needs to be a distance of at least 2 times its height from the solar zone. Any obstruction orientated north of all points of the solar zone is not subject to these requirements. And then any obstruction not located on the roof is not subject to these requirements as well. Now for electrical, the following needs to be present in the construction plans. There needs to be a plan for the location of the inverters and metering equipment. There has to be a pathway for routing conduit from the solar zone. There has to be a pathway for routing plumbing for water heating. So we don't actually have to install any of that. We just have to mark on the plans where those items will go. They just to be outlined to show where they would go if they were ever dropped in, but they're not actually being installed. You're not installing conduit. They're not installing plumbing. They're not installing any equipment. They're just marking where those items will go. Now for single family residences, they need to have a main electrical service panel with a minimum busbar rating of 200 amps and shall have a reserve marked for future solar electric space to allow installation of a double pole circuit breaker. So that electrical panel actually does need to be installed in single family residences. And that's because obviously if they have to ever drop in the solar panel, they have to have a way to wire it into. So that has to be there, and that's specific to single family.